Hello and welcome back to question 4 part 2 and part 3 of the curve sketching question. Now those of you who watched part 1 will know that we have used part 1 to gather 2 out of 3 of the pieces of information you need when sketching a graph, and that is the asymptotes and stationary points. What is left for us to do over here now is to find the axial intercepts. But just in case you haven't watched it, this is what we found. We have 2 asymptotes. One of them is the oblique asymptote, y equals to x plus 2a, and the vertical asymptote is x equals to a. Just zoom out a little bit. The maximum and minimum points are quite a mouthful to say, so I'll just let you read it off the screen over here. Alright, now let's look at the axial intercepts. Alright, so the axial intercepts is when we're going to substitute x or y equals to 0, and I've written here in gray our equations for y, right, in 2 different forms. Sometimes one form is better than the other when substituting x or y equals to 0. So when we substitute x equals to 0, I'm actually going to use this one, because when x equals to 0, then everything goes to 0 and y is equal to 0. That's nice, always. And then we want to find out when y is equal to 0. Again, I'm going to use this form. When y equals to 0, I just have x times x plus a equals to 0, which means x is either 0 or x equals to negative a. Right? So with that, you should be able to sketch your graph, and it should look something like this. With everything put in, yeah, it should look something like this. Yeah, I could have done a better job, but I'm just not very used to drawing on the iPad, so it's a bit squiggly. Yeah, so this is what your graph should look like in part 2. Now let's move on to part 3. Part 3 is quite interesting because we have to add a suitable graph to this diagram, to this same diagram, and we want to solve the inequality x plus x times x plus a over x minus a, which is our f of x. We want our f of x to be less than modulus of 3x. So that just means we have to plot modulus of 3x. Now I'm not going to draw on the same diagram. I've already prepared beforehand. Okay, but how do we draw modulus of 3x? It just means that we can define a piecewise function where modulus of 3x is equals to 3x when x is positive or 0, and it's actually equal to negative 3x when x is negative. So if you do that, this is what it should look like. For values of x 0 or more, it's actually just a 3x graph. When it's less than 0, right, so you have a negative 3x graph. And this green graph is a graph of modulus 3x. Now, we want to solve the inequality of f of x less than modulus of 3x, which means you want the regions of the graph where the green graph is above the white graph. So if you look carefully over here, where are the regions where the green is above the white? Yeah, so this region over here is above white, is above white, is above white, and right at x equals to 0, that's where they intersect. So it is not above, they are equal at this point. Okay, so everything from, I'll say, negative infinity all the way up to just before 0 is fine. 0 itself should be excluded, and then from here to just before a, the green graph is still above the white graph. Once you cross over to the other side of a, you realize that the white graph is above the green until we have another intersection over here. So from this point onwards, let's find out what this is. What's the x value of this intersection then? So let's solve. Y equals to 3x equals to our f of x. So let 3x equals to our f of x, and if you solve this, you will get x equals to 0 as we have expected, and x equals to 2a. So that means this point over here, from x equals to 2a onwards, that's where we have the green graph above the white graph. And if you were to represent that on the number line, you can see that the green graph is above the white graph for these regions, okay, up to 0 but not including 0, okay, and then again up to a but not including a, okay, and finally from 2a onwards not including 2a. Yeah, so how do we express this as an inequality? Well, I think we can first maybe express this part here as x less than 0, not including 0 itself. There you go, x less than 0. Next, we could say, maybe let's choose a different color, red. This region here, x is between 0 and a, not inclusive. And finally, we can have this part over here, x more than 2a. And that is the answer for question 4, part 2. Hope this helped, and I'll catch you in the next video.